You have to report this to the police.
Alright, 6.5 inverse trig functions. So we've done inverses before. Remember, inverses, as far as graphically goes, if I was trying to find the inverse of this, remember they're always going to be symmetrical with the line y equals x. So its inverse would be, oh boy, like that. Did I do that right? That looks pretty good. Okay, so it's symmetrical across the line y equals x. So inverses are symmetrical with y equals x. So if I was looking at just y equals x, just an oscillating curve like that. If I wanted to find the inverse of it, remember it's got to be symmetrical with y equals x. It would be, I'm going to go like this, and it would just keep on going. So this would be the inverse of x, this darkened in curve like that. Now, is this a function as you see it right here?
No.
It's not a function because it fails what test?
Vertical line.
Very good. This fails the vertical line test. Okay, so if we grab the entire y equals sine x function and I find its inverse, it is not going to be a function because this is not a, anybody remember, how did I know that the inverse of this is not going to be a function? Because this function is not, it's been a while, 1 to 1. Did you say that? Anybody?
Yeah, that's what I said.
Yeah, that's what I thought. You just didn't say it loud enough.
Yeah.
Okay, because this one fails the horizontal line test, so then the inverse is going to fail the vertical line test. Okay, so does that mean that we can't have a function out of it? Well, we kind of arbitrarily say, all right, so we can't find we don't have an inverse function for this whole thing. So let's just say we're going to use this much of the graph right there. Well, that portion of the graph is 1 to 1. It passes the horizontal line test, so its inverse is going to be a function also that will pass the vertical line test. Okay, so we only use a portion of sine x. We go from negative pi over 2 to pi over 2. From negative pi over 2 to pi over 2, that's how much of the function we use. Okay, so from negative pi over 2 to pi over 2, that's the portion that we use. So then the inverse of it will look like this. Now remember, the domain and range switch when we go from function to its inverse. So if this domain is negative pi over 2 to pi over 2, then the range of the inverse is going to be from negative pi over 2 to pi over 2. And the range of sine x is from negative 1 to 1. So the domain of inverse sine is from negative 1 to 1. That's what I have written right there. Okay, so that's what the graph of the inverse sine looks like. If we're looking at tangent x, well, this portion of tangent x is 1 to 1. So one period of tangent x is 1 to 1. So that's how much we use. And again, we're going from negative pi over 2 to pi over 2. That's how much of tangent. We know that it keeps on going like this forever, but we're just going to use that chunk of it from negative pi over 2 to pi over 2. So the inverse will look like this. The domain of tangent is negative pi over 2 to pi over 2, so the range of inverse is from negative pi over 2 to pi over 2. Notice the range for this one is all real numbers, so this one is domain is going to be all real numbers. And last one I'll talk about is cosine. We can't go from negative pi over 2 to pi over 2 because this portion actually is not 1 to 1. So cosine is different. We always got to have somebody different. So this one is different because it goes from 0 to pi. That portion of it is 1 to 1. Okay, so from 0 to pi, that becomes the range of the inverse, and from negative 1 to 1, that becomes the domain of the inverse. All right, the most important thing about everything I said is this right here. What quadrants do they exist in? We said inverse sine only goes from negative pi over 2 to pi over 2. So from negative pi over 2 to pi over 2, that's where you'll find inverse sine. Same is true for tangent. Cosine, it didn't work that way, so we went from 0 to pi. So inverse cosine goes from 0 to pi. That's the only quadrants that these exist in. So if you have a negative inverse sine, it's going to be down here. Negative inverse tangent down here, and negative inverse cosine, it's going to be in quadrant 2. Okay, that's where those exist. All right. Questions so far? This will become more clear when I do a couple examples, but this is the most important thing so far.
Why are none of them in the third quadrant?
So third quadrant is between pi and 3 pi over 2. And if you look back at the graph of like sine x, this goes from 0 to pi, 3 pi over 2 to 2. That quadrant 3 is way over here to the right, and we only use this portion of the graph from negative pi over 2 to pi over 2. Good question. Okay, so anytime you're evaluating a function, an inverse function, say to yourself, what angle has a sine of whatever? So right here, inverse sine of 3 square root of 3 over 2. We're finding the angle. Well, what angle has a sine of square root of 3 over 2? What angle has a sine of square root of 3 over 2? So we draw our triangle, and then from our triangle, how big is that angle right there?
30 degrees. 60 degrees.
60 degrees. And in radians, that is pi over 3. So we have our answer. The inverse sine of square root of 3 over 2 is pi over 3. Because it's asking what angle has a sine of square root of 3 over 2. Now we know by now that there are two angles that have a sine of square root of 3 over 2. This angle and this angle right here. Okay, this one is pi over 3. The other one, how big is this angle right here? Waiting for the... How big is this? If this is 60 degrees, this is... How big is this whole angle?
20.
120, which is 2 pi over 3. Okay, what angle has a sine of square root of 3 over 2? Pi over 3 and 2 pi over 3. However, inverse sine only exists in quadrant 1 and in quadrant 4. So we don't include the 2 pi over 3. There's only going to be one answer when you do the inverse trig. In this case, it's pi over 3. Alright, so what if I had the inverse tangent of do -1. Okay, inverse tangent of -1. What angle has a tangent of -1? Remember, inverse tangent exists in this quadrant, quadrant 1 or quadrant 4. What angle has a tangent of -1? Well, this angle right here has a tangent of -1. I know it's down here because it's negative. Now we just have to figure out how big that angle is. It's 45 degrees. 45 degree reference angle. So we're going backwards. So it'd be -45 or negative pi over 4 would be our answer. Okay, don't say it's 7 pi over 4 because that's not in the domain. It's either go up pi over 2 or go back pi over 2. Those are our options. So inverse tangent -1 is negative pi over 4. Alright, I'll have you try one. Figure out what is the inverse sine of -1/2. Give that a shot. What quadrant are we in? Quadrant 4, very good. Okay, so inverse sine of negative 1/2. A negative inverse sine tells us we know for sure it's in quadrant 1 or 4. Since it's negative, we'll put it down here. 1, 2, square root of 3. That angle right there has a sine of negative 1/2 because opposite over hypotenuse is negative 1 over 2. So that is 30 degrees, a negative 30 degrees. So it is negative pi over 6. Raise your hand if you got that. Okay, good. Let's try cosine, just because that one's a little bit different. So what's the inverse cosine of negative square root of 3 over 2? Try that one. Alright, so it's a negative inverse cosine. Inverse cosine exists in quadrant 1 and 2. So negative puts it in quadrant 2. Adjacent over hypotenuse, adjacent over hypotenuse. Angle is 30 degrees. So this angle here is 150 degrees, or 5 pi over 6. Five 45, 90, but the concept is the same. Draw your triangle and tell me how big the angle is. You're looking for the angle when you're doing inverse. What about inverse cosine of negative 1? What angle has a cosine of negative? Say it out loud. What angle has a cosine of negative 1? Some. Alright, so if it's negative 1, that's on the axes. That you have to go to the unit circle thing. That's 1, 0. Oop, that's 1, 0, 0, 1. We were not very good on this on our. Actually, we haven't been very good this whole chapter. Okay, what angle here has a cosine of negative 1? Well, we already know that it doesn't exist down here. Cosine is the x value. So where is the x value negative 1? $180. Good. So our answer is what? Pi.
And what is pi?
Because right there, that's where the cosine is negative 1. Alright, as long as I have this, what's the inverse sine of 1? What angle has a sine of 1? Pi over 2, very good. Okay. What we're going to do now is reinforcing what we're going to explain it any further right now, because hopefully it'll get explained more as we do more. Okay, we're going to kind of stack them. We're going to find the tangent of the inverse tangent of 1. Okay, we have to work our way out. So let's start in the parentheses. What angle has a tangent of 1? And once we have that angle, then we'll take the tangent of it. But let's find that angle. What angle has a tangent of 1? Tangent exists, inverse tangent exists in these two quadrants. With
45.
good, positive 45 degrees. That angle has a tangent of 1 because opposite over adjacent is 1. So 45 degrees is pi over 4. Okay, so our inside is pi over 4. Now we have to take the tangent of pi over 4. What is the tangent of pi over 4? What is the opposite over adjacent of that triangle drawn right there? It is 1. Does it make sense that we found the tangent of the inverse tangent of 1? Aren't these inverse operations? Alright, you would hope that that would always be the case. But it is not always the case, just based off of what quadrants things exist in. So if I wanted to find the inverse sine of the sine of 2 pi over 3, well,
on the inside or the outside,
it does matter. You still have to work your way out. That's a good question. So that's what's a little different with this one. So we still have to work inside first. What is the sine of 2 pi over 3? 2 pi over 3 is 120 degrees, which puts us at a 60-degree reference angle. I told you special right triangles are going to be important. We're doing a lot of them. So what is the sine of 2 pi over 3? What is the opposite over the hypotenuse? Square root of 3 over 2. Good. So the inside, square root of 3 over 2. Now, we have to find the inverse sine of it. Because it's a quadrant thing, inverse sine is positive in what quadrant now? Remember, we're back to inverse now. Inverse sine, what quadrant is it positive in? Quadrant 1, because it only exists in 1 and 4. So, what angle has a sine of square root of 3 over 2? What angle has a sine of square root of 3 over 2? How big is that right there? 60 degrees, or pi over 3. Okay, so the inverse sine of the sine of 2 pi over 3 is not 2 pi over 3. It actually is pi over 3. Okay, so just work your way out. Do this first, and then do that one. All right, I'll have you try. Well, I'll keep going. I want to make it through this lesson. Okay, so what if we have the, this is in your notes, tangent of the inverse tangent of 3/7. All right, and I can make other ones up, doesn't matter. But we're working our way out. Inverse sine, let's ignore tangent right now. Anytime you have an inverse trig, what do you ask yourself? Somebody tell me that.
What angle?
Very excellent. What angle has a, in this case, what angle has a sine of 3/7? Has a sine of 3/7. So we draw our triangle. That's our angle. And we could find the this last side, 49 minus 9, so this is the square root of 40. Okay, we have our triangle drawn. This tells us what our angle is. It's right there. Now, we have to find the tangent of that angle. So it's just opposite over adjacent. So it's 3 square root of 40 over 40, or 3 over the square root of 40. Okay. And the last thing I'll show you, applying product or sum and difference formula. So I have cosine. Let's say I'm trying to find the cosine of inverse sine of 4/5 minus inverse cosine of negative 3/4. Look at problems. Cosine of u minus v. In this case, our u is actually this right here, and our v is this. So we literally just write it out like we would. replacing our u with inverse sine of 4/5 and our v with inverse cosine. So it's all of this stuff. So it's 1, 2, 3, 4 different problems. You evaluate them all like we have been doing, and then just combine and simplify the result. Okay, so it's just 4 times as hard as a simple like cosine of the inverse cosine of -3/4. Figure each of them out and then combine and simplify.